Good morning. In this lecture video, I'm going to explain what is 8051 microcontroller and its architecture and registers. Okay. So first we'll see what is 8051 microcontroller. The 8051 microcontroller, it is an 8-bit controller created in the year 1981 by Intel Corporation. So why it is called 8-bit microcontroller? Since it has 8-bit processor, that means it operates on 8-bit data at a time, and it is the most popular and commonly used microcontroller. So 8051 is an 8-bit microcontroller since it performs operation on 8-bit data, and it is a 40-pin IC and data bus is 8-bit. So this is the definition of 8051 microcontroller. Now we'll see architecture. Architecture means what all 8051 contains. I mean the registers, ALE unit, all those. Architecture of 8051. So the main and most important block is arithmetic and logic unit. So it is an 8-bit. I mean AL is an 8-bit, means it performs arithmetic operations such as addition, subtraction, multiplication, division, and logical operations such as OR operation, AND operation on 8-bit data. And for this ALU we need an input. So those inputs are given through a special function registers A and B. Now we'll see what is A and B. A and B are the 8-bit registers. What's the result of an arithmetic and logical operations. So these registers are bit addressable. That means to say individual bit can be accessed for reading or altering the data without changing the other bits. Individual bits can be altered. That is called bit addressable register. So A register is also called as accumulator because it accumulates the result. I mean it is used as a destination in many operations such as addition, subtraction, multiplication, division, bit manipulation, and accumulates the result. That is why we call A register as an accumulator. Also, the specific usage of A register is it is used for data transfer between 8051 and external memory. As you know, 8051 has an internal memory. If that is not sufficient for our application, we go for external memory. So to transfer the data, I mean either to read the data from external memory or to write the data into external memory, that is will be done through only A register. This is the specific application of accumulator, A register. And for B register, it can be used as a general purpose register to store the data, and specifically along with the A register, B register is used for multiplication and division operation. That means B register holds the second operand of A and multiplication and division operation. Also it holds the result. This is the specific application of B register. Okay. Then so PSW, program status word, it is an output. See in the direction output from the AL. I mean some conditions are happening, like suppose if it is operation is addition, some carry will be affected. So those conditions are given to the program status word. So PSW, program status word, is a 8-bit register and also referred as a flag register. Why? Because flag means a single bit register and it consists of 8 flag registers. So this PSW indicates certain conditions like carry, parity, sign, etc. after execution of certain instructions such as addition, subtraction, multiplication. Right now? And these conditions are indicated by flags. So flags means a 1-bit storage indicates some certain conditions. So and flags are 1-bit register, and these can be tested by a jump instruction. Test means whether the status is 0 or 1, and based on that jump instructions take the decision whether it has to jump to the address or it has to continue with the next instruction. And status of flags are grouped in PSW. That is why it is also called as a flag register. So it is an 8-bit, but only 6 bits are used. Among the 8 bits, 6 bits are used, and 2 unused bits are user definable flags. That means user can define it however they want based on the application and requirement. Among the 6 bits used, 4 flags are called as conditional flags. Indicates condition after execution of certain instructions. And they are carry, auxiliary carry, parity and overflow flags. These are the 4 conditional flags. Remember, PSW is an 8-bit register. Among this, only 6 bits are used. 2 unused bits are user definable. And among the 6, 4 are conditional flags. They are carry flag, auxiliary, parity and overflow. So now we will see this is the bit assignment. So these are the bit number 0, 1, 2 up to 7, 8 bit. So from MSB it is carry flag, CY means carry flag, auxiliary carry, user defined, register select. So we'll see all this in brief. So carry flag. So carry flag used alternate name. As I said, it is a bit addressable register. It can be named as a PSW.7, means this is the PSW and this is 7th bit. And in the instruction either we can say C or we can name it as PSW.7. Used in arithmetic, jump, rotate and boolean instruction. So it is set to 1 when there is a carry after an addition or a borrow after a subtraction. That means it can be used as a carry flag in addition. Also it can be used as a borrow flag in subtraction. Otherwise it is a 0. Also externally, forcefully we can set or reset using an instruction set bit carry C. Clear C. As I said, alternate name PSW.7. No? So here we can write set bit PSW.7 and clear CL or PSW.7. Either we can name it as C or PSW.7. And next one is auxiliary carry flag. So alternate name is PSW.6. That means in PSW register 6th bit. So used for BCD arithmetic. BCD means binary coded decimal digit. So it is set to 1 when there is a carry from lower nibble to upper nibble or borrow from upper nibble to lower nibble. So here we call 8-bit data as a byte, 16-bit data as a word and 4-bit data as a nibble. 4-bit data as a nibble. 8-bit data contains 2 nibbles, lower nibble and upper nibble. If there is a carry from lower nibble to upper nibble, auxiliary carry flag will be set. Or in case of subtraction, if the borrow is needed for lower nibble from upper nibble, it is set to 1. Otherwise it is a 0. So it is mainly used in instruction that performs BCD arithmetic. Okay, fine. Now we'll see one example. So if you want to perform addition of 98H and 88. So here in binary, it is in hexadecimal, it is in binary. So for 9, 1001 and 8 means 1000. This is 8. And here it is lower nibble and this is upper nibble. This is the bit numbers 0 to 7. So usually we start addition from the LSB, least significant bit. Now here it is 0 plus 0, 0 no carry, again 0 no carry, 0 no carry. Here 1 plus 1 means 0, 1 carry. That will be propagated to the next bit. And this carry is called as auxiliary carry flag. Because see, it is generated from a lower nibble, it is propagated to upper nibble. Also, we can say carry from bit number 3. Carry from bit number 3. This is called auxiliary carry flag. If there is a carry in the bit 3. And in the continuation of addition, again 1 plus 1 is 0, carry 1. Again here 1, carry 0. Here 0 plus 0, 0. And see C6. C6 means carry from the 6th bit. Here, when you perform addition of 6th bit, 0 plus 0, there is no carry. So that is called C6 is equal to 0. And when we perform addition of these two numbers, again 1 plus 1 is a 0, carry 1, and this carry is called as C7. That means carry from the 7th bit, also called carry from the MSB. When carry is set, when there is a carry from MSB, carry flag will be set. Carry flag will be set. When there is a carry from bit 3, auxiliary carry flag will be set. Clear, no? So in hexadecimal you can write this result as 2 and 0. And the next one is F0, general purpose user flag. Again alternate name PSW.5, user for general purpose. As the name itself tells, the user can define it however they want based on the application and requirement. And the next conditional flag, overflow, that I am going to explain in next video.